and I want a 180 degree rotation. We don't say through the origin, we say about the origin. Fancy math, excuse me, fancy math talk. So this is my angle of rotation right here. So what you can do is you can use this, or you can use your safety compass, whatever you want to do. I'm going to go through A. Oops. And what I do is I start off by making my A circle, and I put an A in on there to make sure I know that's what it is. And then I create my B circle. So my outer circle's B. And my inner circle is C. So depending on how many sides is going to depend on how confusing everything is going to get. Now I'll use different colors for A, B, and C. So what I want to do is I want to draw the line that goes through the point of reflection, which is the origin in this case, for point A. And think back to the original of what we did, and we're doing a 180 degree rotation, which is how far around the circle? Halfway, maybe? So if I just draw this all the way down here, that's going to cut my circle in half. Now, where's the A? Because it's a straight line, this angle is 180 degrees, isn't it? Yes? No? Maybe so? Yes? So, which circle is A? Is it the outer, the middle, or the inner?
What about just take a look at it?
All right, there's going to be A prime. Now for B, I'm going to do the same thing. So I got an A prime, I got a B prime, and now I'm going to do and find my C prime. and then all you do is connect them. So you could have done this with a double rotation of 90 degrees. I'll show you something else that's pretty cool. So you could do this with the circle, but now let's do the thing with the double rotation. This is actually a lot easier than this. This one's tough because isn't it all messy, right? Yeah, kind of messy. Let's try to do something that isn't quite as messy. So let me get rid of. This is going to be great for the video, having just a black arm in front of it. Alright, let's try to make something not quite as messy. I'm going to take, that's A, that's B, and that's C. Nope. You can put them in wherever you want. Just make sure they're in a box somewhere. Now I want to do another 180 degrees. So 180 degree rotation. Using a double reflection. It's weird looking at the computer screen. You guys see everything as it happens. Up here there's a delay. Messes me up. Just messes me up big time. Now, a double reflection. We're going through the origin again. So we're going through the origin. Yes? Now, what's the angle between the two lines that have to be through the origin if we're doing a 180 degree rotation? What's 1/2 of 180 degrees? 90 degrees. Now, are there two lines that are built in to the coordinate plane that both intersect the origin, which is right here, that have 90 degrees between them? Well, first off, are there two lines that go through the origin? Yes. Yes, there are. What two lines are those? The axes, the x and the y axes. Now, what's the measurement of the angle between the two axes? 90 degrees. So, is that 1/2 of 180? So if I reflect through one and then through the other one, am I going to get a 180 degree rotation? Yeah. Now, 180 degrees, how far along the circle is that? Is it halfway? What's the if I went from one point here all the way around to back to B, how many degrees do I travel? 360. So what's halfway? 180. So this is perfect. Now, the next question is, does it matter which way I go? If I go to the right, if I go clockwise, I'm going to end up down here because I got to go through that one and that one. If I go through this one and this one, I'm going to end up in the same spot. Because 180 degrees is one of those special things. It's going to be halfway around the circle. So it doesn't matter which way we go, we're still going to end up halfway. So let's reflect. Let's take C. C is how many away from the y-axis? Well, in my case, it's 3. Whatever you guys have, it is what it is. So 1, 2, 3. There's C prime. And now I'm going to take C prime and reflect it through, and I totally put the axes upside down, but we can deal with it. That's at, what, 8 up there? So I have to go 8 down here. There's C double prime. Now B here is at, it would be a technically -4, but since I put everything upside down, it doesn't make any sense. But -4, we'll deal with it. So I'm 4 away from 2, so 1, 2, 3, 4. There's B prime. Then I'm 2 above, so 2 below. There's B double prime. Now A is at 7, 1, 2, 3, 4, 7, 4. So I need to go to 7, 4 here. There's A prime. Now it's 1, 2, 3, 4 above, 1, 2, 3, 4 below. There's A double prime. And I'm going to violate my own rules by just connecting them without the straight edge. So does that work out pretty good? One of the things is take advantage of the built-in parts here. And I want to show you one more thing. But does this make sense? That, all right, if I'm going to do a 180-degree rotation, I could do a double reflection through 2 lines that intersect at 90 degrees. It just so happens that the axes intersect at 90 degrees. Does that make sense? So you don't actually have to draw the circles. You don't even have to draw the lines. You could just reflect and reflect. Make sense? Now, I'm going to flip this over and actually make it look right. And here's what I want to do. A 45 degree. No, let's do a 90 degree rotation. About the origin. And I want to go clockwise again. And I'm just going to take one point A right here. Now, I want to use the double reflection again. Because, believe it or not, the double reflection is a whole lot easier. But what angle between the lines do I need? With a double reflection, I got to take 90 and multiply it by 1/2 or divide it by 2. What do I get? 45 degrees. The unfortunate thing here is I only have lines that are 90 degrees. But what's special between 90 and 45? .45 is how much of 90? Half of it. So if I can cut one of these quadrants in half, and since I want to go this way, if I can cut, say I can cut the first quadrant in half, I'll get my 45 degrees. Do you know a line that's going to cut this in half? I'll give you a hint, since you guys are so full of energy this morning. Y equals X. So I'm looking at 1, 1, 2, 2, 3, 3. That's the one that's going to cut it right in half. So if I do this, that's y equals x. And for y equals x, remember that you're going to get the points like 1, 1, 2, 2, 3, 3. And this is going to create a 45-degree angle. So remember that. Now, if I want to go clockwise, I have to go through this guy first, and then this guy second. Now, since this is vertical, this is going to be nice and easy for us. 1, 2, 3, 4, 5 here, so I have to go how many spaces to the right? 5. 1, 2, 3, 4, 5. So I'm right here. So that's my A prime. Now, you see how this line cuts this box in half? And I'm here where these two lines hit. Can I figure out exactly where I'm supposed to be on the other side? Using some logic. Where these two hit. It actually works out kind of nice that way. Use the symmetry of what's going on in this case. And then if I wanted to be all fancy, just like Iggy. You didn't see that one coming, did you? No. I didn't see that one coming. It took me a while to figure out who it was, to be honest with you. Now, if I drew the lines between A and A double prime, and I did the reflection across the y-axis and then through y equals x, what should the angle be? Now, just using the eyeball test, does that look like the pencil lines look like it forms a 90-degree angle? I hope I did it right. It looks pretty 90 degrees to me because it hits there and it hits there. So, that guy right there, being able to cut a coordinate plane in half is going to make your life a whole lot easier for that.